Hello everyone to my channel Techify with Adil. Today in this video we will be discussing about Azure Storage Services, and also we will see in detail about Azure Blob, like that's one of the storage service. So earlier in my previous video we have discussed about Azure Storage accounts, then Azure Storage redundancies available. So here we will be seeing the storage services. So Azure Blobs, this is a massively scalable object store for text and binary data. It also includes support for big data analytics through Data Lake Storage Gen 2. Next will be Azure Files. So managed file shares for cloud or on-premise deployments. Azure Queue, a messaging store for reliable messaging between application components. Then Azure Disk, so block level storage volumes for Azure VMs. Then Azure Tables, no SQL table option for structured non-relational data. So these are the Azure storage services. So we see benefits of Azure storage. So durable and highly available. Redundancy ensures that your data is safe if transient hardware failure occur. So you can also opt to replicate data across data centers or geographic regions for additional protection from local catastrophic or natural disasters. Data replicated in this way remains highly available if an unexpected outage occur. Next is the secure. So our data will be secure in Azure storage account as it's encrypted. It has an encryption option. So Azure Storage provides you with a fine-grained control over who has access to your data. Next is scalability. So Azure Storage is designed to be massively scalable to meet the data storage and performance needs of today's applications. Then it's managed. So Azure handles hardware maintenance, updates, and critical issues for your the data store services. So we just going to maintain the data only. Accessibility. Data in Azure Storage is accessible from anywhere in the world over the internet, that's HTTP or HTTPS. Microsoft provides client libraries for Azure Storage in a variety of languages including .NET, Java, Node, JS, Python, PHP, Ruby, Go, and others, as well as mature REST API. Azure Storage supports scripting in Azure PowerShell or Azure CLI, and Azure Portal and Azure Storage Explorer offer easy visual solutions for working with your data. So these are the benefits of using Azure Storage Services. So here we will see detail about Azure Blobs. So Azure Blob Storage is an object storage solution for cloud. So it can store massive amount of data such as text and binary. So Azure Blob Storage is unstructured, meaning that there are no restrictions on the kind of data it can hold. So Blob Storage can manage thousands of simultaneous uploads, massive amounts of video data, constantly growing log files, and can be reached from anywhere with an internet connection. So blobs aren't limited to common file formats. A blob could contain gigabytes of binary data streamed from scientific instrument, and encrypted message from another application, or data from custom format for any app you are developing. So in general, like Azure Blob doesn't have any restriction with the kind of data or how the data is being uploaded or what format it's being uploaded. So it doesn't have any limitations. So you can upload any data formats with any kind of data as well. So like videos, like binary data, or it's going to be very big log files, like having continuous uploading. And also if you are going to have simultaneous uploads, like from multiple sources, the data is being uploaded to the storage service simultaneously, also it can support. So the one advantage of blob storage over disk storage is that it doesn't require developers to think about or manage disk. Data is uploaded as blobs and Azure takes care of the physical storage needs, as we see in the previous slide. So all the physical related things the Azure takes care of. We just have to manage the front end only. Blob storage is ideal for serving images or documents directly to the browser, storing files for distributed access, streaming video and audio, storing data for backup and restore, disaster recovery and archiving, storing data for analysis by an on-premises or Azure hosted service. Accessing the blob storage. So objects in the blob storage can be accessed from anywhere in the world, like from HTTP and using HTTP or HTTPS. Users or client applications can access blob via URLs, the Azure Storage REST API, Azure PowerShell or CLI or Azure Storage Client Library. The storage client libraries are available for multiple languages including .NET, Java, Node.js, Python, PHP and Ruby. So you can access from anywhere. You can access with multiple ways, like use URL, can use storage, REST API, use Azure PowerShell, Azure CLI, Azure Storage Client Library, and can use multiple available programming languages as well. So blob storage tiers. So data stored in the cloud can grow at an exponential pace. To manage costs of your expanding storage needs, it's helpful to organize your data based on attributes like frequency of access and planned retention period. Data stored in the cloud can be handled differently based on how it's generated, processed and accessed over its lifetime. Some data is actively accessed and modified throughout its lifetime. Some data is accessed frequently earlier in its lifetime, with access dropping drastically at the data ages. Some data remains idle in the cloud and is rarely, if ever, accessed after it's stored. To accommodate these different access needs, Azure provides several access tiers which you can use to balance your storage costs with your access needs. So even generally in our local storage, when we're saving in our laptop and our external hard disk, not every data we access every day. Like there will be some folders which we'll be accessing every day. There will be some folders and files which we will be accessing only like particular periods, and there will be some folders and files which we will be never, very rarely or seldom we access. So just we put into the disk, just keep it there. We very seldom access. So these are the different kinds of timingly accessing to the data. So even based on this, the tier has been derived. The tier storage, blob storage tiers has been derived based on this access frequency. So we see here hot access tier, cool access tier, cold access tier and archive access tier. So hot access tier is optimized for storing data that is accessed frequently, like very often is being accessed. So example, like images on your website. Then cool access tier is optimized for data that is infrequently accessed and stored for at least 30 days. So like invoices of your customers, like once in a month accessing or such things. So storing data that is infrequently accessed and stored for at least 90 days is cold access tier. Then the last one is archive access tier. So appropriate for data that is rarely accessed and stored for at least 180 days with flexible latency requirement. It's something similar to our email archive, we say, like, because email archive usually we don't access very often, but we still need it, something like that. The following considerations apply to the different access tiers. So hot and cool access tiers can be set at the account level. The cold and archive access tiers aren't available at the account level. So hot, cool, cold and archive tiers can be set at the blob level during or after upload. So data in the cool and cold access tiers can tolerate slightly lower availability but still requires high durability, retrieval latency and throughput characteristics like hot data. For cool and cold data, a lower availability service level agreement SLA and higher access costs compared to hot data are acceptable trade-offs for lower storage costs. So archive storage data offline and offers the lowest storage cost but also the highest cost to rehydrate and access the data. So it's like when you are using archive storage access, so it's going to be the lowest storage cost because we very seldom accessing it. But when you are going to access it, the cost for rehydrating and accessing the data is higher. Whereas the hot access tier, the storage cost itself is going to be higher, as it should be available every time for users to access to the data.